The fifth question here is based on functions and calculus, and the question says, a particle of unit mass undergoes one-dimensional motion such that its velocity varies according to the function v of x is equal to beta x raised to minus 2n, where beta and n are constants and x is the position of the particle. The acceleration of the particle as the function of x is given by. In the question, we have v of x, velocity as a function of position, and that is given as beta x raised to minus 2n. And based on that, we should get to a of x, acceleration as a function of position. Now, we know that acceleration a is d by dt of v. Acceleration is the first order derivative of velocity with respect to time. And that gives us a is equal to d by dt of v is given as v of x, and that is equal to beta x raised to minus 2n. So we have beta x raised to minus 2n here. Now, this is where this question becomes different from such similar questions. And that is because here, if velocity was given as a function of time, we could easily take the derivative of that function with respect to time and get to the answer. But here, velocity is given as a function of position or x. So we need to take the derivative of a function of x with respect to time. And that is where we'll have to use the chain rule. We'll see how that is being done. So here we have a is equal to beta, taken out because it's a constant, d by dt of x raised to minus 2n. Now, a will be equal to then beta into d by dt of x raised to minus 2n would be minus 2n x raised to minus 2n minus 1 multiplied with dx by dt. That is according to chain rule. When I take d by dt of x raised to minus 2n, I'm taking the derivative of something raised to minus 2n with respect to time. And that is minus 2n multiplied with something raised to minus 2n minus 1, and that multiplied by d by dt of something, because this x here is again a function of time. So we'll have to finally take the derivative of that x with respect to time to complete the differentiation. That is chain rule here. And dx by dt, you know, is v, and v is already figured out here as v of x, velocity as a function of position. Now, you know that v of x is beta x raised to minus 2n, so this would become a is equal to beta into minus 2n x raised to minus 2n minus 1 multiplied with v of x here, and that is beta x raised to minus 2n. Now, to get to this answer here, we can use the direct formula, which is also available, that is a of x from v of x can be directly written as a of x is equal to v dash of x multiplied with v of x. And this is also possible. There is a direct formula which would help you do this. That is, a of x from v of x can be calculated by multiplying v dash of x, first order derivative of the velocity function with respect to x itself, that multiplied with the velocity function again. This is a direct formula, and that will get you to this step directly. Now, you can choose to do it in your own favorable method or favored method. Now, that is, a is equal to minus 2n beta square x raised to minus 4n minus 1. Now, if we match this answer here with the options, we have the correct option D here, and that is the answer. We have multiplied all the factors here in this equation to get a is equal to minus 2n beta square x raised to minus 4n minus 1, and that is option D. So the correct answer for this question is option D.